I want you to just imagine something for a second. Imagine waking up tomorrow morning and, like, before you've even had a chance to swing your legs out of bed and pour your first cup of coffee, your entire inbox has been completely triaged.
Oh, that is the dream right there.
Right. Like, all the crucial emails from your VIP clients are just summarized. The promotional junk is completely ignored, of course. And there are fully written, highly contextual, polite drafts just sitting there waiting for you to hit approve.
Yeah, which usually takes an hour of just staring at the screen.
Exactly. And here is the absolute kicker. You didn't have to hire an executive assistant to do this. And you certainly didn't need, an advanced engineering degree to build the system that did it.
I mean, honestly, it sounds like science fiction.
Yeah.
Or, at the very least, something reserved for a massive enterprise tech company with a dedicated development team and just a bottomless IT budget.
Oh, for sure.
But the thing is, it is suddenly very, very real.
It is. So today we are unpacking a massive stack of sources to explore what is really a total paradigm shift in how we automate our digital lives. We've got developer documentation on this new tool called Claude Routines. We have a really fascinating case study on building a Hacker News scraper
Mm-hmm.
and an incredibly detailed transcript of a Firefly's AI integration. So our mission for this deep dive is to basically figure out how this new tool closes the loop on AI assistance. It takes Claude, which you probably just know as a really smart chatbot you type questions into,
The chat interface. Yeah.
and it turns it into a fully dedicated autonomous automation platform.
Okay, let's unpack this.
Well, to really understand the scale of what is happening here, you kind of have to look at the overarching context of how digital automation has actually worked up until this exact moment. Because historically, if you wanted to automate a task, say moving data from a web form into a spreadsheet, and then, sending a Slack message.
Layered stuff. Yeah, very standard. You had to rely on no-code or low-code drag-and-drop builders, platforms like N8N or Make.com. And, I mean, they were revolutionary a few years ago.
Oh, absolutely game-changing at the time.
Totally. But Claude Routines fundamentally changes the interface. Now, users can kick off incredibly complex automations via schedule triggers, webhooks, or API requests, and they are doing it by relying almost entirely on conversational English.
Okay, actually, let's pause and define some of those terms for the listener real quick, because the sources throw around words like webhooks and APIs, like, a lot.
That's a good idea. It gets jargon-heavy fast.
Yeah. So if you've never built an automation, an API is essentially a digital menu. It's how two pieces of software agree to talk to each other. App A asks App B for a specific item on the menu, and App B just hands it over.
Right.
And a webhook is basically just a reverse API. So instead of you constantly asking the restaurant if your food is ready, a webhook is the restaurant actively calling you the second the food comes out of the kitchen.
That is a really great way to picture it, actually. And in the old way of building automations, catching that webhook, and doing something useful with it, well, it required this massive, intimidating chain of logic.
Oh, yeah.
Like in our sources, there's a case study of someone building a Hacker News scraper using a legacy platform like NEM, taking that initial event, the scheduled trigger to pull data, and then outputting it into a formatted Slack message required this giant, complicated middle layer.
Yeah, that middle logic is where all the heavy lifting lived.
Exactly. And it was rarely intuitive for a beginner.
No, not at all. I always picture those legacy setups like building a really complex plumbing system. Like, you are the plumber and you have to manually thread every single copper pipe yourself. You are physically dragging and dropping these little visual nodes onto a screen. Then you click into each node, you set up the API credentials, handle the messy authentication screens, and meticulously map specific variables. You literally have to tell the system, take the data from field A, parse it into text, and, shove it into field B.
And if the shape of that data changes even slightly.
Oh, it's a nightmare.
Yeah. Say a website updates its API and changes a field name from first name to F name. Your rigid copper pipe just bursts and the whole workflow crashes.
Right.
And then you have to go back in and manually fix the plumbing.
See, but I'm reading through this Hacker News scraper example, and I kind of have to push back a little here. Isn't there inherent value in that kind of granular control? Like, when you physically map the data step by step, you know exactly how the machine operates.
I mean, sure, it feels safer.
Right. If something breaks, you know exactly which pipe burst. So why fix what isn't broken? Why replace a system that gives you total transparent control?
What's fascinating here is that while granular control does feel safe, it is also incredibly rigid, fragile, and just astronomically time-consuming. Claude Routines effectively solves that clunky middle problem of automation.
Okay, so how does it skip the middle?
Well, instead of spending your entire afternoon manually configuring a dozen different logic nodes and troubleshooting data formatting errors, this new method is a literal one-to-one overlap in functionality. But natural language handles the orchestration.
Huh. So instead of being the plumber laying down rigid pipes, it's more like, I don't know, the pipes themselves are just gone.
Yes.
The AI acts like a waterbender. It dynamically catches the incoming data in midair, looks at it, and routes it exactly where it needs to go, adapting to the shape of the data in real time.
Okay, that is a much more accurate metaphor. You simply provide the system with high-level instructions. Think of it exactly like writing a standard operating procedure, or SOP, for a human employee.
Just writing it out.
Yeah, you tell it what you want done in plain English. And the underlying AI model, like Claude Opus, takes that natural language SOP and executes it within a standardized cloud container. It figures out the logic, the routing, and the data formatting entirely on its own.
Okay, but my brain is hitting a bit of a technical wall here. Let's look under the hood for a second. Claude is a large language model. At its core, it is just a text prediction engine. It predicts the next most likely word in a sequence. It doesn't have hands. It can't physically click send on a Slack message.
No, it can't.
So how is a text predictor actually executing a command in the real world without those rigid nodes?
That is the million-dollar question, really.
Oh,
And the answer is a mechanism called tool use or function calling. When
yeah.
Claude Routines receives your plain English instructions, it isn't just generating text to talk back to you. The platform provides the AI with a list of available tools.
Like the connectors.
Exactly, like a Gmail connector or a Slack connector. When the AI model decides it needs to send a message, it generates a highly specific machine-readable string of code in the background. The Routines platform catches that code, translates it into an actual API request, and fires it off to Slack.
Wow. So it's essentially writing the necessary code on the fly, executing it, and then going back to reading your instructions.
Exactly. It completely abstracts away the technical layer. You don't see any of that code.
That is wild. Let's bring this down to earth and look at the actual morning inbox triage example from the developer docs, because the amount of time saved here is staggering.
It really is.
Here's how that routine is structured in practice. You go into the Claude Routines interface and you set a scheduled trigger. The user in the example wakes up around 5:20 a.m., so they set the trigger for 5:10 a.m. Then they simply attach a Gmail connector.
Which is just a secure integration giving the AI permission to peek into the inbox.
Right, standard OGolf stuff. But the natural language instructions given to that routine are what really blew my mind. The user essentially types, pull my unread emails using the Gmail connector. For each unread email, check if there are any pre-existing conversations with that contact. If there are, pull those too for context. Then draft polite replies based on the context of the task. Finally, use the Slack connector to send me a summary.
See, the inclusion of that context checking step is what elevates this from a dumb automation to a smart, agentic workflow.
Yeah, a traditional N8N workflow would struggle immensely to dynamically search a past conversation history.
Right, to read it, understand the nuance of your relationship with that specific sender, and then draft a tailored reply. It would just see a new email webhook and trigger a generic pre-programmed action. Here, the AI is applying reasoning to the task.
But wait, if I'm giving an AI the keys to my email inbox and telling it to apply its own reasoning, I'm honestly terrified it's going to misinterpret, like, a sarcastic email from my boss and fire back something completely inappropriate. Or worse, access sensitive data it shouldn't be looking at. How is this actually secured?
Oh, that's a very valid fear. But the documentation addresses that directly through an underlying mechanic called managed sessions.
Manage sessions.
Yeah, a managed session is essentially a siloed, highly secure container for an AI agent.
No, so like a digital quarantine.
Exactly like a quarantine. When you are building these interconnected networks of automations, you want them strictly separated. You do not want the agent that handles public customer support tickets to have free reign over the agent managing your personal inbox.
Right, that would be a disaster.
Managed sessions ensure they are securely compartmentalized. So the email agent spins up, does its specific job within its secure sandbox, leaves the drafts for your human approval, and then spins down. It cannot independently decide to start emailing your contact list.
Okay, that makes me feel a lot better. And the result of that 5:10 a.m. trigger is that by 5:20 a.m., you wake up to a single Slack direct message. It gives you a high-level summary of your unreads and tells you it has drafted a polite decline to a vendor and an acceptance to a client, all just sitting in your Gmail drafts folder. And you are asleep while this happens.
It acts autonomously to reach the definition of done. And that is just a relatively simple schedule-based example. The Firefly's transcript in our sources outlines a much more complex business use case using API triggers.
Yes, the business proposal generator. Here's where it gets really interesting because it moves beyond just organizing data and into actual revenue-generating work.
Fireflies, for those who don't know, is a service that joins your digital meetings, transcribes the conversation in real time, and stores the text.
Super useful tool.
Definitely. The source outlines a routine triggered the exact moment a sales call ends. The event is a webhook that essentially hands the massive text transcript of that call directly to Claude. And the natural language instruction is incredibly simple. It's basically, I am giving you a transcript. Create a full, customized business proposal for this prospective client.
And inside its managed session, the AI takes that raw transcript. It doesn't just copy and paste. It actively reads the deal terms discussed, understands the client's specific pain points, and automatically generates a highly specific, polished proposal.
Exactly.
In the source's case, it was pitching an AI content writing marketplace that matches businesses with vetted freelance writers. It extracts all the necessary data from the conversation to customize the pitch perfectly.
It finds the client's company name, the budget they mentioned in passing at the 15-minute mark, the specific deliverables they asked for, and it weaves all of that into a professional template.
And here is the stark reality check from the source that you really need to hear. Building that exact proposal generator in a legacy system, designing the logic, formatting the text outputs, connecting the different app nodes. Well, the developer notes that previously that would have taken 2.5 to 3 hours of intense, frustrating human labor.
Easily.
With Claude Routines, integrating this API event-based system takes about 2 minutes. You just write the English instructions, attach the connector, and you are done.
It fundamentally alters the barrier to entry. You no longer need to understand data formatting to build a highly complex operational system.
With an ease of use that dramatic, I know exactly what the temptation is. You hear this and you want to log into your NAN or Make.com account right now, highlight every workflow you've ever built, hit delete, and move everything over to Claude Routines.
Oh, I'm sure people are doing exactly that.
But the source has spent a significant amount of time warning against doing exactly that. There is a vital catch regarding the infrastructure that we have to talk about.
There's always a trade-off in systems architecture.
Always. But before we get into the negative trade-off, I do want to mention one incredible feature regarding migrating those old workflows, just in case you actually do want to move one. Let's say you have a massive NAN workflow. The sources note you can go into NAN, highlight all those drag and drop nodes, and just hit copy. What you are actually copying is the JSON syntax of the entire visual workflow.
Let's clarify JSON for the listener.
Right, good call. JSON is basically just a highly structured text file. Think of it like a digital filing cabinet with perfectly labeled folders that apps use to pass data back and forth. You take that big block of JSON code, paste it into a Claude window, and use a routine generator skill to translate it. Claude essentially looks at the blueprint of your old rigid plumbing system and in seconds rewrites it into a natural language SOP. Once it's in Claude, you can just type, update this so it sends me a message in Slack when it finishes. In 3 seconds, the model edits the routine on the fly. No dragging nodes, no manual HTTP requests.
It's an incredibly powerful bridge between the old paradigm and the new. However, we really have to look at the underlying economics of how these two different systems actually operate.
Yeah.
This is where the reality check comes in.
Right.
Traditional no-code platforms operate entirely in the domain of what we call compute.
And static compute is essentially just raw server processing power. I think of it like a train running on a track. The tracks are laid down perfectly by the developer. The train, the compute, just has to follow the steel rails. It doesn't have to think. It just goes. And because it doesn't have to think, running that train is incredibly cheap.
Exactly. When you build a workflow with fixed logic, those rigid nodes and pipes we talked about, running that logic costs fractions of a fraction of a cent.
Practically free.
Right. Claude Routines, however, does not operate purely on cheap track-bound compute. It operates in the domain of tokens.
Right, because it's an AI model. It has to actively think its way through the natural language instructions every single time it runs. If traditional compute is a train on a track, A token-based AI model is like paying a professional taxi driver to navigate through a busy city.
That's a great analogy.
They have to read the map, look at the traffic, adapt to roadblocks, and make real-time decisions to get you to your destination.
And paying a dedicated taxi driver every single trip is inherently much more expensive than buying a train ticket. Every time the Claude routine fires, the model is consuming tokens. It uses tokens to read your SOP, tokens to analyze the incoming webhook data, tokens to decide which tools to call, and tokens to generate the final output.
It adds up.
It does. This requires massive GPU processing power for the LLM inference, not just simple CPU logic.
I'm looking at the cost breakdown in the sources, and the shift from compute logic to token logic is significant. So if token-based execution is noticeably more expensive per run, where is the actual tipping point for a business owner? When do you actively choose the expensive taxi driver over the cheap train?
If we connect this to the bigger picture, the answer lies entirely in how we value human labor.
Okay.
The point of this paradigm shift is not to blindly port every single highly optimized, cheap-to-run end-to-end workflow over into Claude just because it's the new shiny thing. If you have an automation that processes 10,000 rows of spreadsheet data every hour and it runs perfectly on NANN for pennies, we'll leave it there.
Because it would bankrupt you in tokens.
Exactly. A token-based AI would cost you a fortune to run that volume. The calculation you need to make is about upfront human time versus ongoing API costs.
Let me see if I have this right. Let's say you need a new automation built today for a specific client onboarding process. You map it out on a whiteboard, and you realize that wrangling the specific API data, fighting with authentication errors, and dragging all those nodes around in a traditional builder is going to cost you 3 hours of deeply frustrating, hair-pulling labor.
And your time as a business owner or a manager is highly valuable. Let's say your time is worth $100 an hour. That's a $300 build cost in human capital just to get the system working.
Right. So in that scenario, it makes complete economical sense to one-shot the build as a Claude routine in 2 minutes. You willingly pay the slight premium in ongoing token. It costs 5 cents every time it runs instead of a tenth of a penny because the massive savings in upfront human labor far outweigh the execution cost. You are essentially using tokens to buy back hours of your own life.
Precisely. You use the heavy, rigid compute for massive, repetitive data processing where the rules never change. You use the flexible, token-based AI for complex, reasoning-heavy tasks where setting up the logic manually would drain your time and energy.
So what does this all mean? When we strip away all the API keys, the JSON code, and the webhooks, what is the core takeaway for you listening as you navigate this new landscape? It means we are entering an era where virtually all non-human FaceTime steps in a business can be automated without technical friction.
Yeah, that's the big takeaway.
Generating post-call emails, drafting business proposals, monitoring a document to see if a client signed it, triggering an onboarding calendar notification. All of this can now be orchestrated purely through conversational English. You don't need a technical background anymore. You don't need to know how to code. You just need to know exactly what you want the system to do.
And understanding this underlying shift, this movement from rigid, cheap compute logic to flexible, expensive, but highly capable token logic is the absolute key to mastering the next wave of automation. It is how you harness the power of these tools to scale your work without feeling overwhelmed by the technology itself. The tools have finally adapted to how humans naturally communicate, rather than forcing humans to act like machines to process logic.
The digital plumbing has completely disappeared. We aren't threading pipes anymore. We're just telling the water where to go.
We are, but that leaves us with a lingering, slightly uncomfortable thought to consider as we wrap up.
Oh, lay it on me.
If the traditional meat and potatoes of building complex digital logic is now being handled entirely by natural language processing, well, what happens to the inherent value of traditional technical know-how?
That's a good point.
As we move forward into this token-based future, will the most successful builders and entrepreneurs of tomorrow be the ones who can write the most elegant, highly optimized code, or will they simply be the ones who can write the clearest, most precise, standard operating procedures in plain English?
That is a fascinating question to chew on as you check your newly triaged morning inbox. Thank you so much for joining us on this deep dive. We'll catch you on the next one.